First of all, you can note this down. Okay. Everybody knows this. Start it in the group. Everything back. Last time we started this topic, engineering design methods, and we said that design includes anything which you are doing new. It could be a product, it could be a process, it could be a system. We went through the design process, and first of all, we went through how many aspects of design we have in civil engineering: structural design, environmental design, materials engineering, and so on and so forth. And then we went to the design process, which was shown in this flow diagram. Okay, and it's an iterative process, so that means you do it once, you get back to the client may say, okay, do something more. Okay, or you may do it now, and after a few years, you have to do the same thing again for future of the project. Okay, so that's why it's an iterative process. We went through the different stages of the project, and something which is not mentioned in this flow diagram is documentation, feedback, and communication. Okay, so it is involved in every stage of the flow diagram. Okay, you have to document whatever you are doing, make the report, drawings, and everything. Okay, document it, keep a record. You have to take feedback from the people who are working with you, and you have to communicate everything to your entire team. Okay, so this is part of the loop. It's not written there, but it is at every stage. Every stage you have to do this. Okay. Today we are going to start with some of the considerations of design in civil engineering. Every field has its own important aspects. Okay. For example, if you were a software engineer, okay, you would not have to listen to me. It would be blessing, right? But here you are in civil engineering. But if you were in software engineering and you were designing a software, okay, then you don't have to worry about many of these things. Okay, in software engineering, you will think, okay, my software should work very fast. It should do more things, right? Things like this. Okay, but in civil engineering, we have some other things we need to consider. Okay, what are those things? First thing is safety. Okay, make sense? Okay, safety is of two types. Safety for civil engineering projects, two types. One is a normal one. What is the normal one? Your project is safe under normal operation of its use. So we have a building. Okay. This building will have chairs, right? Normal. Okay. It will have students. Okay. Maybe at one time 200 students in the building. Normal. If the building can take the load of these chairs and the students, it's safe, right? It is safe. Okay. You have another building which is for, let's say, a factory. Factory will have machines, right? So the factory can take the load of the machines when they are working. Building is safe. Factory is safe. Okay. This is the standard you follow in Bahrain, because alhamdulillah in Bahrain we don't have any special issues. Okay. For example, if you go to some areas of Pakistan, they have earthquakes. Okay, you know earthquakes, right? What do they call it in Arabic? Earthquake in Arabic? Nobody knows. It doesn't come. Earthquake in Arabic. Yeah. Say. Don't tell her. I am asking. Tell me. Salsa. Keep an eye on. Okay. In some parts of Pakistan, we have these zilzals. Okay. They happen. Small ones happen every year. The small ones happen every year. Okay. Now, every year doesn't mean every day. Get a point. Every year, a small ones, and maybe after 4 or 5 years, we may have a big one. Okay. Recently, you had the earthquake in Turkey, right? Okay. Turkey and Syria. Two countries, right? Turkey and Syria. Anyway, so it was a big earthquake, right? Now if I am designing a building over there, my building is safe under normal load. But I know in this area there are earthquakes. So I have to make my building safe against the earthquakes as well. Right my point? I cannot call my building safe or my structure safe if I do not consider the safety under the special conditions. Got my point? Clear? Okay? So we have a normal safety and we have a safety which is under special conditions which are for specific areas. Okay? So in some areas they have snowfall. So your building is safe under normal conditions. But when there is snowfall, which happens 6 months every year, the building is not safe. The roof may fall, you see cracks appearing. So that means your building is not safe. Got my point? Nobody can say, I designed this building in Bahrain, it was taking the whole load of the factory, nothing was happening, I'll do the same thing in Canada. No, Canada has snowfall 8 months of the year. Okay? You cannot use the same design, it will not be considered safe. You may say, no, it's safe under the load which the building is having. No, you have to consider the conditions of that area as well. Got my point? Clear? Okay? Safety of two types. Then we consider durability. Durability, I mentioned last time as well, long-term sustenance of the load. And I give the example of the guy going to the gym. Okay, he goes to the gym and first day he takes 20 kg and 30 kg. Okay, and then he comes back, he's on the bed for next 6 days. He took the load, right? He took the load for 1 day, but now next 6 days he cannot do anything. Okay, so yeah, he had the strength, but he does not have the durability. He cannot take the same load every day. Got my point? Okay. If you know the drivers, the bus drivers. Okay. If you ask them, like how often they go to the workshop, somebody may say after every 2 weeks. Do you take your car after every 2 weeks to the workshop? If you do, then sell it. Okay. Do you take your car every 2 weeks to the workshop? No. Okay? Or you don't know. Father does it. What? For sure not having 2 weeks, right? Otherwise you would. But why there are those bus drivers or those van drivers are taking their vehicle every 2 weeks? Because of the load. If you take the same amount of load in your car, so for example you take 6 people, car can have 6 or 5. Okay, 5. Okay. If you take 5 people every day from one location to the other, your car will need more maintenance. Because now you are having heavy load every day. Okay. But if you take it like once every week, no problem. Get my point? So there is taking the load, so structure can take the load, yes. But if the same load is there for next 30 years, will it take it? Okay? That's durability. Don't do this. It should. It should. Okay. Why we are talking about durability? Because of our investment. Okay. Civil engineering projects have a lot of money involved. Initial cost is very high. Okay. For a bridge, the initial cost can be in millions. For a building, it can be in thousands. Okay. Or even hundreds of thousands. You cannot take the same investment every year. You cannot make the same investment every year, right? So once I did the investment, I need to work for a long time so I can justify my investment, right? I don't have that much money, 50,000 every year. I cannot do that. Nobody can do that, right? Okay? So because of the investment, I need this project to last longer. Okay? So that's why I said don't do this. Okay? It should. It should last longer, otherwise your money is wasted. The money is wasted. Okay. You build a bridge for 1 million BD and you have to, it does not take the load for 20 years. Your money is wasted. You cannot build a bridge after 2 years. Invest 1 million BD every 2 years. Get the point? Okay. So because of the investment, we need our projects to last long. If it doesn't, then your money is wasted. Okay. Then we have sustainability. We will talk about sustainability later on in detail. But sustainability deals with the environment. what is the impact of your project on the environment. We have to talk about that as well, and we will cover that in detail later on. Then we have to talk about, or then we have to keep in mind, cost effectiveness. Our project should be cost effective. Costs are of two types. Costs are of two types. Initial cost, maintenance cost. You have initial cost and you have maintenance cost. Okay? So again, going back to the example of the car, you may have a car which is very cheap. Okay? So the initial cost is very low. Okay. You have so many cars available. You go buy them. Buying a new car of that company is much cheaper than buying an old Corolla. Okay? They are much cheaper. So the initial price is very low. But their maintenance is high. If you take it to the mechanic, you say, well, I do not have the parts of this car. You have to buy it from Germany or something, and it will take like 200 days. Got the point? Okay. So you bought the car because it was very cheap. But now the maintenance is very high. Okay? Then, so we need to balance it. We need to balance it. Okay? This is normally the case. Except for iPhones. Everything is iPhone. You buy it, you maintain it. Expensive. Okay? So normally the case is initial cost is low, maintenance cost is high. So you need to balance it. I cannot make it too cheap and make the maintenance too high. Got my point? Okay? So you have to balance it. It's called as cost effectiveness. Functionality, every project, every structure has a purpose. It should fulfill the purpose. And I keep on giving the example of the bridge. Okay? We have a bridge for cars, we have a bridge for people. Both are on the roads. You can use steel or any concrete or any such material, both of them. But will their design be same? No, right? One is for car, the other one is for, even the size is not same. Even the size is not same. Okay? So the design is different according to the, why? Because of the function, right? Because of its purpose. Got it? Okay. Then we have aesthetics. Aesthetic means how does it look? How does it look? We have seen Burj Khalifa, right? You have gone there or seen it, right? In the picture. How does it look? Go to the back. Huh? Yeah, but how does it look? Too long. Okay, fine. Come on. Go to the back. Yeah? Very good. Yes. Good, huh? They can make the same tall building like a box. They can do it like this. You have seen the design. It's very complicated, right? Okay. So they can make a complicated design like this. They can make a box this long, right? It's easy. Huh? Why did they make a complicated design? Maybe this design has taken much extra cost. Why did they do it? Because of aesthetics. How will it look in this area? Huh? A big tall box in the whole area will not look good, obviously. Okay? People will make fun of it. Okay? It will not look good. Why it is very important for us? Because it is this is something related to the client. The client says it should look good, right? And I'm doing the construction. I don't care. I'll do the construction, take my money and go, right? But the client says I have to use it. It should look good. Okay? Who are our clients most of the times? People who are doing residential projects. If you go and look around the construction going around, you will see few of them maybe malls and shops. Very few of them roads or pipelines. Most of them residential. Buildings, apartments, villas, most of them. Okay? Any construction happening around the road, any construction happening around your house, 99.9% is the chance that it's a house. Okay? Or a residential building. Now if you are doing something to live, you want it to look good. Right? You want to live in something which looks good. So most of the projects have very important aspect of aesthetic. Okay? The client client wants a building to look good. Maybe the client is doing a factory or a bridge. Okay. You don't care what it looks like. Okay. But 90% of our clients are owners of residential projects and they care about aesthetics. In many buildings, the cost of aesthetic can go up to 50% or more of the project. Okay? And even if it does not go up to 50%, it's a very big amount. 20-30% is normal. Okay? 20-30% of the cost just going to look, okay, the paint, for example, the paint and the lights. Okay? These small items, and they don't take like much time. The whole thing can be done in 1 month. If the project is 6 months, this whole thing, the aesthetic part, can be done in 1 month. Okay? But in that 1 month, you will spend like 40% of your budget. Got the point? So aesthetic is important because it's important for the client, especially residential clients. Okay? And it takes a very large part of the cost of the project. Got it? Okay. Then we have accessibility. What is accessibility? The amazing thing is, whenever I come to this point, somebody enters. Okay. What is accessibility? This door is part of accessibility. Okay. This door is accessibility means to enter. Accessibility means to enter. So this door is. If there was no door, how will we enter the room? You will have the class on the ground, right? Very good, but not in this week. Okay, so this door is part of the accessibility. There is the main door of the building, right? What do you have outside the main door? How do you get to the main door? The main gate of the building. There is an elevator. I didn't see it. Stairs, right? Yes, stairs. Okay. So stairs are part of accessibility. You cannot get to the main door without the stairs, right? So stairs are part of accessibility. Now, can anybody use these stairs? What if somebody is on a wheelchair? They cannot use it, right? Okay? They cannot use it. Clear? Do we have any floors on the top? No. But we have it in the other buildings, right? We have it in the other buildings. So how do you get to the top floor in the other buildings? Elevator, right? Okay? So again, maybe somebody, and we have the stairs as well. Maybe somebody cannot use the stairs, but they can use the elevator. What? The elevator is part of accessibility. So when you are designing, you have to make sure the users, all types of users, can access different parts of the structure. Okay? So I have a ramp for this floor, but I have a floor on the top, and there is no elevator, there is no ramp. So that means somebody who is walking with a chair or on a wheelchair cannot go to the top. Got the point? So we have standards which are related to accessibility. The government will set the standard that you have to provide a ramp, you have to provide the stairs, what should be the height of the stair and so on. Okay, we have to follow the standards. Okay, then we have environmental impact. Okay, and again it's something related to sustainability. Okay, environmental impact is related to sustainability. Our project can impact the environment in 3 ways. Our project can impact the environment in 3 ways. It can cause water pollution, noise pollution, or air pollution. Okay, our project may cause water pollution, noise pollution, air pollution. These are 3 main ways of disturbing the environment. Okay, water pollution means you are throwing something away in the sea or the river which is harmful for the quality of the water. Okay, so you are throwing away some chemicals or some waste product or some oil. This all is harmful for the water. Okay. You are creating too much noise, so noise pollution. You have a factory and that factory is the machine in the factory create too much noise. So you are creating noise pollution. Okay. Or you can have, what was the other one? Air pollution. Your project is emitting harmful gases, carbon dioxide, carbon monoxide, okay, sulfide or something, which is again harmful for the air. You have to make sure that you don't do this, okay, otherwise you will make a disturbance for the people who are living there, people or species, animals, birds, okay, and so on. fishes and so on. Compliance. Every stage of the project must comply with the regulations of the country. Okay, I already mentioned that we have regulations. We have to provide the door. Okay, even these windows are part of the regulations. Even the window, providing the window. Okay, it's part of the regulation. You cannot build a classroom which doesn't have a window. Got it? Yeah. Even this type of window is not, it's against the regulation. Okay, because you see the window, can you open it? No, right? We have to do what? Yes. You have to break it, right? So this should not be. This should not be. Okay, but the point is, there are regulations for doors, windows, parking spaces, and so on. You have to follow all of them. Okay, lighting, air conditioning. There are regulations for all of them. Okay. Site conditions. Civil engineering projects do not finish or do not complete in an enclosed space. You have to go on the site and do something. All our projects. Yes, you may do the design in the office, but will it complete your project? I did the design. Project finished? I still have to do it, right? Okay. So I cannot finish the project in my office. I have to go in the site. Okay. And unlike other fields, my site is not the same space. For example, if I'm a mechanical engineer working in a factory, my site is the same, right? Today, tomorrow, after 5 years, same factory, right? I'm working in the same factory. Civil engineering projects, I will construct the road at this location. The next bridge will be at some other location, right? What the point? So our projects need work on the site, and our sites keep on changing. Okay. If you ask any engineer that how many projects you have done, he will say 50. Ask him or her how many on the same location, they say none. Because our projects are long term, right? Once you construct the building, next 30 years nobody will do the building again on this location. There's already a building. Got my point? Okay. And even if you do, for example, you did the road project now. After 30 years you come, or after 5 years you come to the same location and do the bridge on the same location. The location is same, but are the site conditions same? Site conditions are not same. Something changes on the site. Maybe weather has changed. Maybe the ground has changed. What am I? Okay. So site conditions include, for example, you have taken surveying, right? Surveying, you have talked about topography, terrain. So these conditions, these things are part of site conditions. Soil, okay, the ground, okay, the environment, the weather, all these are part of site conditions. You have to keep site conditions in mind when you are doing the design, because it will affect your project. Got it? Okay. Then we have utility. Utility means the essential services which you need. When you are in this structure, when you are in this project, when you are using this project, what are the services you will need? Without that, you cannot work. Okay? Somebody give me an example for this room. If you want to have a class in this room, what are the things which we should have? Essential, necessary. Chairs. Okay, what else? AC. Lights. Okay. What if I ask about your home? What are the things you need, essential at home? Huh? Air conditioning? Electricity? Okay, what else? Wi-Fi? Okay. Huh? Bed? Okay. Water? Kitchen? Okay. Gas in the kitchen and so on. So all these things come under utilities. Utilities is any essential service you need at that place. Okay? Water, gas, electricity, AC, all these things. Clear? So you have to make, now we are using electricity here, right? Are we producing electricity here? Is this electricity produced here in this building? No, right? It is not. No, don't think. We don't do this. Okay? It is transported from somewhere, right? So utilities include two types of considerations. You have to supply it and you have to transport it. Okay? Same thing with the gas, same thing with the water, right? The water which you are using in your home, you don't have a river, right? Under your home. Okay? So the water has to be transported, the gas has to be transported. The utilities has the use aspect and the transportation aspect. You have to make sure that both of these things are available in your project. Utilities are available and they can be transported easy. Okay? Then you have to also consider the future expansion. Okay? So, especially for government projects. This is very, very important for government projects. Okay? Because, the government cannot say, we build a road at in this area, now we are done. We will not do anything now. Can they say that? If there is a problem after 5 years, they have to do something, right? They are responsible. The government is responsible. Okay. So, have you seen any road project recently? Give me any example for any road project which has just finished, or maybe finished in the last 3-4 years. Any location? Yeah, any road. Al-Fateh, right? On Al-Fateh highway, they did not build the highway from the scratch. The highway was there, right? The highway was there. They did the expansion. They did the expansion. So when they were designing the highway for the first time, when Al-Fateh highway was designed for the first time, somebody must have thought that in future we will do this extension. We will make a bridge, we will make a tunnel. Somebody must have thought. Otherwise they couldn't have been able to do it now. Okay? Because you are doing something on the old design, right? If the old design cannot take it, then the new design is useless. Okay? A very easy example. I have this building, no floors, right? No floors on the top. Let's say after 10 years I decide I need 2 floors on the top. Okay? But when I built this building, I did not think about these 2 floors. So if I add extra floors, will this building take it? No. I did not consider the load of those 2 floors when I was designing it now. Okay? So you have to consider future expansion. Otherwise, what will happen? I did not consider the 2 floors now. If I need 2 floors, I have to demolish this whole building and make it again. What am I? Okay? Because right now this building cannot take 2 floors extra. So if you have a building with 2 floors, I have to remove this one and make a new design complete from the scratch. Okay? So this will mean what? All this money is wasted because I have to demolish. Okay? Clear? So you have to consider future expansion as well, and by going through all these things, you make sure that you fulfill the needs of the people, you provide them infrastructure. As I mentioned, our main aim is to provide infrastructure to the public. So you have to consider all these things in providing the infrastructure. Okay. In the previous class, we have gone through the design method flowchart for any engineering project. Okay. But these activities are more relevant to construction projects. These activities are relevant to construction projects. Okay. We start with problem identification and definition. Problem identification and definition. So, what does it mean? I told you, problem does not mean something is bad. Okay? Problem means what I want to achieve. Problem identification is what I want to achieve. So, in this stage, you define your objectives. What you want from this project. What you want from this project. For example, I need housing for 10 people. This is my objective. I need housing for 10 families. This is my objective. Then, what are the requirements for these objectives? To fulfill this objective, what do I need? I need land, right? I need money, I need time, I need an engineer, I need a contractor. These are the requirements. Okay? And then we have constraints. Constraint means what? I explained it last time as well. What is the meaning of constraint? Yes. Limits. Okay, I have limits. Okay. Yes, I have requirements, but for each requirement there is a limit. To fulfill my objective, I need money. Money is my requirement. But do I have infinite amount of money? I wish, right? But I don't. Okay? To fulfill my objective, I need land. Do I have infinite amount of land? No, there is a constraint. What am I? Okay? So, constraint means the limit of your resources. Got it? Where? Okay. And scope includes all these things. All these things combined are called scope. Scope includes objective, requirements, constraints. Okay. Then we start with the feasibility study. Feasibility, a rough translation of feasibility is possible. Possibility study. Is this possible? What I am thinking, is this possible or not? Okay. And we have to check the possibility from three aspects: technical, economic, environmental. Okay. You have to check if the project is possible from technical aspect, from economic aspect, and from the environment aspect. Okay. So for example, somebody says that I need to build housing for 10 families. Okay. When he looked at the constraints, he found he has a space of this room. Can we have 10 families living here? Okay. So it's not technically possible to have 10 families in this much space. What am I? Okay. Yeah. So it's not technically feasible. Okay. Yeah. Economic feasibility. Somebody comes and says, no, I can build a very tall building in this much space, but since it's a short space, I need a lot of money. I'll make it whole steel, top to bottom. Okay. So normal building is around 50,000 pt. This one will take 150,000 pt. But I can make it. I'll make housing for 10 people like this in 150,000 pt. So it is technically feasible, but I don't have the money. So it's not economically feasible. What am I? Okay. Then we have environmental feasibility, which means is it good for the environment or not? Okay. So for example, the government says we will build a new road in this location. Okay. There is land available. There is money available to the government. So technically no problem. Okay. Economically no problem. The road will be very cheap. It's very basic design. We have so much space available. No problem. Okay. But that space has trees and plants and grass. Okay. So to make this road, I have to remove all these things. Okay. So no technical problem, no economical problem, but there is environmental problem. Bottom line? Okay. So you have to look at all these factors for your project. Then we go for the designing. You go for the designing. Design happens in stages. What I mentioned last time as well. Detailed design takes a lot of effort. So we don't directly jump on the detailed design. We start from very basic and we see if it is possible, do we need to make any changes. So whatever option we have to see, you will see in the initial stages. Final design will come later. Okay. So you can see three steps related to design. Conceptual, preliminary, detailed. Conceptual is like a sketch. Okay. This is your building, this is what it will look like. Okay. These many floors, these many rooms. This is the shape of the building. It will look like a triangle or something. Or a circular building or something. This is conceptual design, no details, nothing. Just a shape. Just a sketch with no details. This is called conceptual design. Then we go for preliminary design. Preliminary design will show the location of your project in the area. Where will be this project layout? Preliminary design will show the layout of the project. So, few more details. In the preliminary design, you are adding few more details. So there will be now drawings. Drawings about the layout of the building, the elevation, the floor plan, and so on. Okay? But still not detailed design. Okay? This is like architectural design. The second step is like architectural design. So you know how many floors you will have, how much area you need, and that's it. Clear? Okay? Okay. Third stage is detailed design, which concerns us. Us meaning civil engineers. Okay, this is the third stage. So now you prepare detailed drawings. So it's no longer about the layout. Now you will show what is inside the structure. Okay, so it's no longer okay, I will have a beam here. No, what is inside the beam? How many bars? What quality of material? Okay, so detailed design will include all these things now. It will have all details about the inside of the structure. Okay, type of material, dimensions, detailed dimensions, even the small parts as well. Size of the column, size of the bar, size of the beam, thickness of the roof, everything. Okay, quality of material, you will use concrete of this strength, steel of this quality, and so on. Clear? So this is the detailed design part, and you can see it comes later on. We do not start with the detailed design because we want to see if it is possible or not. Okay, then we go for construction planning. In the previous slide, I showed you project planning. This is the planning of the whole project. You are designing the project, right? After the design is finished, now I will start with the planning of the construction part. This is only planning of the construction part. The previous slide was showing the planning of the whole project. The requirement, the objective, the preliminary design, and feasibility and everything. Okay, this is the planning of the whole project. Now we are moving towards the planning of the construction part, construction process. Okay. Construction process is mainly, or in this planning, we are dealing with how much time we need, how much money we need. Okay. We will divide our work into small parts. We have to build the 10-story building. Okay. This is the whole project. But the first part will be excavation. Second part will be foundation. Third part will be the column. Fourth part will be the beam of the first floor, beam of the second floor, then the roof of the first floor, roof of the second floor. See, so we make it into small activities. Okay. For each activity, we will define the time and the budget. Okay. We will define how many resources we need. Okay. To finish the excavation, what machine I need, how many people I need, how much time I need, how much money I need. Okay. So in construction planning, in short, in summary, we prepare a timeline, a schedule. In this schedule, we show the activities. Activity 1, this time. 2, this time. 3, this time. With the activity, I show the resources. In this activity, I need this many people. I need this machine. I need this much money. Okay. So with every activity, you will see the time and the resources. Okay. Resources include money, people, machines, tools, everything. One more. Okay. A construction plan is like a schedule. It's a timeline. But this timeline includes the activities and the resources and the money and everything. Okay. According to that, you will decide with the client about the payment. Okay. You tell him, okay, to start the project, I need 10,000 BD advance. Okay. You say, okay, 10,000 BD advance, no problem. The next installment, after you finish 10% of the project. Okay. So your construction plan also includes these things as well. Okay. When you will do the testing, when you will do the inspection, all these things are included in the construction plan. Then you start the construction process. Now the construction work has started. Now you are working on the site. Okay. Now you are doing the actual construction. Got it? Clear now? Okay. You know the construction, right? Okay. During construction, you have to follow all the standards and design. You are not doing anything from your own. You already have the plan, you already have the design. You are just following it. And you already have the standards. Okay? In construction, you just follow the standards and the design and the plan. Got it? We try to do as little as possible from our side. Because even if we make a small change, it will change the whole project. Okay? So we don't do this. Then testing and commissioning. You finish the project, you go to the client, I finish the project, give me all my money. And he will give it to you. What do you think? No. He will do what? He will check. Okay, he will do the testing for material, he will do the testing for dimensions, he will do the testing for purpose and utilities and everything, right? So that is testing. After testing, if he approves, he will give you the money, he will take a hold of the project. Until the client has not tested, you are responsible for the project, client may say, no, you did not make this window properly, make it again. So you are responsible, right? At this point, you are responsible. Once you do the commissioning means handing over. Okay, you approve the project, I finish my work, take it. This is the record, this is the key, and clear? Commissioning means handing over the project to the client. Okay, this happens after testing and approval. Okay, then we have operation and maintenance. This is the longest part of the project. This building. Okay, what did I say about the projects? Our projects are what? How many years? 2 years? 6 months? 6 months? Okay. So I build a building and 6 months again, then I build another one, right? Civil engineering projects are what? Not how many times? How long? For how long they should remain? Decades, right? In decades, 20, 30, 40, 50 years. There are some projects which are built for 50 years. Or some parts of the structure which are built for 50 years. Okay? So, you did the construction, in 1 year construction is finished. So everything up till now finished in 1 year. Next 50 years, the last one. Operation maintenance, right? This operation maintenance can affect the life of the project as well. Okay, the project is designed for 50 years. I go back to the example of the car, because you don't know what is happening with your car, right? You should know. So you have a car, and the car is supposed to work for 10 years. Okay? Will it work for 10 years without any maintenance? For you, yes, right? But you are not doing it. Right or wrong? Very honest. Okay? The car will not even work for 10 months without any proper maintenance. Okay? It will need tire change, it will need oil change, it will need refueling, it will need servicing and so on. Okay, clear now? Okay. So if you don't do this, what will happen? The same car which can work for 15 years, 20 years with maintenance, proper maintenance, the same car will stop working after 6 months if you don't do proper maintenance. So very long-term process and very important for the project. Without this, the project will not finish its life. Okay. In the design process, we use many tools, many machines, many softwares like AutoCAD, like MATLAB, and there are many other softwares as well which you will go through. Okay. We have regulations and the standards which we need to follow and so on and so forth. Okay. Okay. So we talked about sustainability earlier as well, and it is related to the environment, right? Sustainability is related to the environment. So there are two definitions of sustainability given here. Okay, both of them are very close to each other. The topic is very important and it is very hot topic in the current scenario. That's why we are discussing it in detail. Okay. So sustainability means, according to one definition, sustainability means meeting the requirements of the client, meeting the requirements of the project, without compromising the future generations. I'm doing something which is good for now, but it has some harmful effects which will show in the future. So this is not sustainable. Okay, even in future it should remain good. Okay, so sustainability means meeting the requirements for now without damaging the future. Okay, and what are the things we need to consider? We need to consider environmental aspect, social aspect, and economic aspect. Okay, so you have a project which is very good, very nice, but it has harmful gas emissions, or it is disposing harmful chemical in the water. Okay, so it will destroy future generations, right? Okay, so environmentally not sustainable. Okay, or people don't like it. Okay, future generations, your design is such that people or the new generation will not like it. people who are living in that area do not like your design. Okay, so it's not sustainable. This is social aspect. Then the economic aspect you understand, right? Okay, to make the project economically sustainable, we should have less cost now and also less cost in the future, maintenance. I gave the example of the car. A cheap car, but high maintenance. We don't want this in the project. Okay, so you need to balance. Okay, so we need to consider if you miss any of these things, your project is not sustainable. Okay, if the project is harmful for the environment, if the project has high maintenance cost, if the project has low acceptance of the people, it's not considered sustainable. Okay. Next definition, same things, right? See, integration of environment, social, and economic aspects into your construction and design decisions. Okay, same thing. Okay, so sustainability includes three main things: environment, economics, and social aspects. Okay, and you have to, again, future generations are mentioned here as well. You don't have to only worry about now, you have to worry about future as well in both these. Certain things which can increase the sustainability of your project, certain points. For example, the first maxim is reduce, reuse, and recycle. Reduce means construction projects take a lot of resources. Okay, these resources are combined: land, space. Okay, if you don't use that space, somebody else can use it, right? Okay, we use aggregates. Aggregates are what? Natural material. We use petrol, gas, oil. What is this? Natural resources, right? So if you reduce their use, you will be doing good for future generations. They will have more of these resources. If you consume less, others have more. Got the point? This is reduce. Try to reduce the use of resources in your project. It will be good for cost as well and will also benefit others. Then we have reuse. Reuse means if I can use some material which I have already used at one side, if I can use it at the other side, I can do it. Very common in construction projects. They have equipment, excavator. Same excavator for 10 projects, right? They are reusing it. Okay. Next point, recycle. Okay. So something you have used, you use it at some other place. What is the difference between reuse and recycle? Anybody? Reuse and recycle. What's the difference? We need to change, yes. So if I take this chair and put it in the other room as it is, this is reuse. Okay? I take it from here, put it in my car and take home. I do not buy it. But if I do that, this is reuse. Okay? But if I remove the different parts of the chair and make something else from the same parts, this is recycling. Okay? You are using on the paper and then you use the same paper to do something else, this is reuse. Okay? But you shred the paper, you put it into pieces and then you make something else out of it, this is recycling. Okay? There's a difference. Use renewable resources. Renewable resources are those resources, when you use them, they do not burn out, they do not get consumed. For example, oil. If you use oil, oil is burned. It changes into something else, it's gone. Your car, when it uses oil, petrol, it uses it, it's gone, right? It's consumed. But if I use a solar cell, if I put a solar cell, the solar cell is taking energy from what? From sunlight, right? Is the sunlight reducing because of that? No. If I have a wind turbine, the wind turbine takes energy from wind, right? When it takes energy from wind, the wind gets less? No. It is still there, right? So these are called as renewable resources. Okay? The use of renewable resources, no harm, right? No loss. You use something and that thing is still there. Best scenario, right? Okay? I'm using something and it does not get reduced. So I spend money and I still have the same money. Something like that. Okay? Use energy efficient resources, so all electronic items, again except iPhones. All electronic items are now energy efficient. You will see the tag. If you buy a new fridge, a new AC, you will see the tag, energy efficiency. Always control. Always good. Okay. So energy efficiency to reduce the use of resources. Design for durability, make sure the project can sustain in the long run, and consider life cycle impact, meaning after the project is finished, not the construction project. What will happen? So after building is constructed for 50 years, after 50 years are finished, what will happen to the building? Can I destroy and use the material somewhere else? Can I use the building for some other purpose? This is called life cycle impact. So life cycle is the end of the life of the project, not the end of the construction of the project. Okay? So after the life of the project finishes, where can I use the same material, the same structure somewhere else? Alright?